lesson 7-4, and we're talking about properties of similar polygons. Shh. Quiet, please. And we're at 5-3. So what we're going to do is talk about what makes two polygons similar. Okay, they're still talking and I don't know why. I'm doing notes and people are talking and aren't starting their notes. That doesn't make sense. Okay, ladies and gentlemen, if you leave this room and I see bottles of water on the floor, as I have been seeing on a daily basis, I will outlaw bottles of water in the classroom and you will have to drink outside and not have them out. So if you want to be treated with respect, you need to treat the room with respect as well. I'm not your mother and I'm not going to clean up after you. Okay, and the custodian, it's not his job either to clean up after you. So, similar polygons. We talked about this. They are polygons with the same shape. But in order for them to be the same shape, there needs to be something that's the same between the two figures. Paul, you remember? Not the lengths of the sides aren't the same. Nope. What needs to be the same are going to be the angle measures. If the angle measures change from your original shape to your new shape, then you actually physically change the shape. What's different are the lengths of the sides. Okay. How are they different? Well, they're what we call proportional. And proportional for our sides means that I'm going to do it underneath here. Corresponding sides have the same scale factor. Okay. So, listening to how I'm describing these similar polygons, which of our transformation gave us similar polygons? Right. Yeah, so this is really, we're going to be focusing on dilations. Okay? So dilations are similar polygons. They have the same angle measures, but the lengths of their sides are proportional. They have the same scale factor. Okay, so I'm going to give you an example of what polygons, similar polygons would look like. I'm going to show you different symbols that you may not have seen before. So these are two similar polygons. This is just more notes. Nope, more notes. So we're going to call this triangle ABC. Thank you. And triangle XYZ. Now over here, I'm going to tell you that they're similar. Sam? Shh. So the first thing that you need to note is that symbol that if you take Spanish, that looks like a tilde. It makes the ñ sound in Spanish. That means the shapes are similar. That means that they are the same shape, but their sides are in proportion. Okay? When I see that relationship right there, here's what it tells me. It tells me that angle A is congruent to angle X. Now, how did I know it was A and X? The order of the letters correspond. So A was in front, X was in front. They're going to correspond. Okay? And then that can also mean that the measure of angle A is equal to the measure of angle X. So one deals with the object about angles, the other deals with numbers. So when I put an equal sign, I'm dealing with numbers. When I put that congruent sign, so we're going to say this one means similar, and this one means congruent. Okay. Now another way that I can symbolize that those angles are congruent is I can make a little arc. So angle A and angle X are congruent because they have the same number of arcs coming out of them. Okay. I can also say that the measure, or that angle B would be congruent to which angle on the other side? What does B correspond to? Y. And then I could also say that the measure of angle B is equal to the measure of angle Y. And then what I can do is not do one arc, but two arcs now. So I just increase the number of arcs to show a new relationship. So you might see double arcs. That means those two angles have the same measure and therefore are congruent. And then I also have angle C, and what is it congruent to? Angle Z. And we can say the measure of angle C is equal to the measure of angle Z, and then I can make 1, 2, 3 arcs, showing that they're congruent. Okay? Now, in addition to showing that the angles are congruent, I can show that the sides are proportional, and how I do that is I create ratios of the sides. So in other words, the length of AB, so here's your AB, that's going to correspond to the XY. How do I know that? 1 arc, 2 arc, that's your AB. X has 1 arc, Y has 2 arcs. So that's going to correspond to XY. Actually, let me do this. Okay. And then you can also just look at the lettering up in the triangle ABC is similar to triangle XYZ. What if I wanted to talk about a ratio of side BC? What corresponds to BC? YZ. Okay, good. And what corresponds to AC? XZ. Okay? So anytime I'm telling you that I have similar polygons, I know all the angles are congruent. I know all the sides in ratio have the same measurement. Okay? So that's something really important. So we've got a tilde that means similar. A tilde over an equal sign means congruent. Exactly the same. Okay? So what I want to do is talk about a couple of examples of what you're going to see. So again, what's matching here are the corresponding sides. So angle A corresponds to angle X, angle B corresponds to angle Y, angle C corresponds to angle Z, and so on and so forth. All right, so 2 types of examples you guys are going to get is you're going to be given pictures with numbers, and your job is to determine are they similar or not. Okay? So now we're going to do examples. Zach A., I sure hope you're with us because it doesn't look like it. So the first example says determine whether rectangle JKL is similar to rectangle MN similar to rectangle MNPQ, and then explain. Okay, I'm going to draw a picture. Don't sit there and make all these. It's two rectangles. They have 4 corners. So that means you have 4 vertices. Okay? You can handle this. So this is HJKL. This is MNPQ. In addition, I'm going to put some symbols. And I'm going to add some values. Because these are rectangles, opposite sides would be congruent. So, in order for us to determine whether rectangle HJKL is similar to rectangle MNPQ, I'm going to need to look at all of the angles, the corresponding angles, and see if they're congruent, and I'm going to have to look at all of the corresponding sides and see if they have the same scale factor. Okay? So the lettering, the order that they listed the letters is the order of the correspondence. So H corresponds to M, so I'm going to write this over here. So we have HJKL. We have MNPQ. So when we're looking at angles, we look at them in pairs like this. And is angle H the same as angle M?
Yeah.
Yeah. And how do we know? How do we know that angle H and angle M are the same? Nope. Kyler? They're both right angles. Notice the little red box in the corner? That means they're right angles. So that tells me that angle H is congruent to angle M. Okay? How about angle J? Is it congruent to angle N? Yeah, they're both right angles, so they're congruent. What about angle K and angle P? Are they congruent?
Yes.
They're both right angles, so they're congruent. How about angle L and angle Q? Okay, yeah, they're both right angles. So basically, we've met half of the criteria. All the angles match. Now we have to look at the sides. So what we're going to do is form ratios. And how we form ratios, it's more of looking at it 2 at a time. So for example, HJMN. Okay. So what we're going to do is look at what's the ratio of the length of HJ to the length of MN. So what's the length of HJ? 7. And what's the length of MN? 10. So we have 7 to 10. So that's the ratio. Do we have another set of sides with that same ratio?
Yes.
What sides would that be?
L and Q.
So we've got KL is 7 and PQ is 10. So that they would be the same. Now, the deal, though, says that all the sides have to have the same ratio. So let's look what happens when we take JK and we compare it to NP. Well, JK is 3 and NP is 6, and that simplifies down to 1/2. Is there another side that has the same ratio as 1/2? Anything else that's going to give me 1/2 when I, yeah, HL and MQ. So the question is, do all 4 of those match up? Do they all have the same ratio? So we've got HJ and MN are equal to each other, but they're not equal to JK and NP, and they're not equal to HL and MQ. Even though HL L, M, Q, and J, K, and P have the same ratio. All 4 of them don't have the same ratio. So our only conclusion can be that no, these 2 rectangles are not similar because all sides don't have the same scale factor. So we just write the rectangles are not similar because all sides do not have the same scale factor. Okay. So in the next example, and again, these are like what you're going to see on your homework, what they're going to do is give you 2 figures and they're going to tell you they're similar. And our job, Talia, you're going to be spending time with me after school today. Thank you very much. Because you think having a conversation with somebody else is more appropriate than listening to me. Marcy, you'll also get detention if you can't seem to focus. Okay, so this is my last warning. So the next one I'm going to give you is that we have 2 quadrilaterals. Oops, let me change colors. So we have quadrilateral, just means a 4-sided figure. W, X, Y, Z is similar to quadrilateral, oops, A, B, C, D. Okay. And then we're going to draw out the 2 figures. So this is our ABCD. Notice that the letters always go either clockwise or counterclockwise. They don't skip around. And then we have W, X, Y, Z. Because these shapes are similar, that means angle A corresponds with angle W, angle B corresponds with angle X, angle C corresponds with angle Y, and angle D corresponds with angle Z. Now, why this is important for you guys to pay attention to those number of arcs is that I know there's one on homework where the shapes aren't in the same orientation. That not only did they do a dilation and a translation, which this is moved from one to the other, they've also done a rotation or a reflection. So what you need to do is to see what corresponds is pay attention to those arcs, because that's going to help you. Question? All right. Now, in addition, I'm going to give you some values. So the length of AD is 13, the length of CD is 10, and the length of BC is 12. The length of WX is 24, the length of XY is unknown, it's M, and the length of YZ is 15. Okay? So you might be asked to, A, describe the transformation. Okay? So you're looking that they're not the same size, so that tells you you have a dilation going on, and then you also notice they're not in the same location, so we've had a translation. So it really doesn't matter what order, because the 2 will end up giving you what you need. So you have a translation. Notice I'm not saying anything more than that, just describing the transformation, a translation and a dilation. Okay? Now, telling me that the shapes are similar also tells me that I know the length of AB over the length of WX will have the same ratio as the length of BC over the length of XY. Will have the same ratio as the length of CD to YZ. Will have the same length as AD to WZ. Now, it's really important that your letters correspond. So A and W correspond, so they need to be one above the other. So what I want to do is look at which of these ratios do I have numbers for. So do I know what the length of AB is? No, they didn't give it to us, so guess what? We aren't going to use this one in any kind of calculation to help us. Do I know the length of BC? Yeah, what's the length of BC? 12. Do I know the length of XY? Do I know the length of XY? Yeah, they've written something there. What did they write? M. That's okay. We can write that. And then, do I know the length of CD? Okay, what did they tell me there? Do I know the length of YZ? 15. Do I know the length of AD? 13. Do I know the length of WZ? Oh, so that means I can't use this one. So what we know is that the sides of similar polygons are in proportion. So the next question we're going to be asked is find the missing length. So proportion means I take two ratios that are equal to each other. So I take the two ratios that I could find values for, even if one value is an M, and now I'm going to solve this proportion when I set two ratios equal to each other for M. Now, who can remember how to solve a proportion? You guys did this probably 6th and in 7th grade. Desi, you remember? Okay. So we're going to multiply. I always like to multiply with the variable one first. That's just my habit. So we're going to do what's called cross products, and we're going to multiply on the diagonal. So when I multiply m times 10, I get 10m. Then it gets set equal to the product going the other direction, 12 times 15. So what I get is 10m equals, what did we say that was? I'm trying to remember what we had. I don't remember. It's like one something. One. I don't think it's 180. Let's see, we get 30 placeholder. Oh, yeah, it is. It's 180. So we get 180. And now I just divide both sides by 10. So I get the missing value is 18. Okay? And so that's something that you guys are going to be working on in your homework, is creating the scale factor, creating it twice. There's going to be one piece of the scale factor is going to be a variable, and then your job is to do cross products and solve for the missing piece. Okay? So that's what you guys are going to be working on in your homework. You've got the two different pages. So again, question 2 in the first set on page 548, the orientation of the two shapes are not the same. So you're going to have to use the clues of the arcs, what vertex corresponds to what vertex. Okay? And then some of them are very easy to figure out what goes with what. So get working on your homework.